Hello guys, welcome back. Today we're going to be going over um, functions, and basically we're doing exponential functions, and for this one specifically we're modeling antibiotics. So the question we have today, and is also like the last one ripped straight from my review, is suppose you initially take an 800 milligram antibiotic that enters your bloodstream immediately. 3 hours later, there is a 300 milligrams of antibiotic left in your bloodstream. Suppose the effectiveness of the antibiotic wears off when the amount in your bloodstream reaches 50 milligrams. Find an exponential function modeling the amount of antibiotic in your bloodstream as a function of time. So the first thing we need to know is how do you write one of these equations? And honestly, it's pretty simple. Um, you're going to write an equation like this. So y equals a times b to the x. So x is going to be, if you're doing like a graph, x is going to be along the x-axis, obviously, y is going to be along the y-axis, and a and b are going to be constants throughout. So we have two values of y already. We have the 800, so I'm going to put it here, and we have the 800 there. We have the 300 right there. So we have the 300 there. And the way you can tell is we're modeling it as the function of, at the bottom it says as a function of time, which means, and it's modeling the amount of antibiotic in your bloodstream. So the antibiotic is going to be the dependent variable, and the amount of time is going to be the independent variable, right? Kind of back to a science question right there. So you have 800 at the beginning, right? So it's really going to look something like, and again, we're going to turn this into better notation later. But at, actually, we're going to change it now. We're going to change y. It still is the same thing. We're going to make it a for antibiotic of t, and t is going to be time. And we're going to change this to t as well. And so at a of t, so a of 0, which equals 800, right? So this equals a of 0, and this is going to be equal to a of 3 because it's going to be 3 hours later. And we're actually just going to get rid of all the rest of this because we don't really need that anymore. We understand what that is. We're going to write two separate equations. Sorry about that. 800 is going to be equal to a times b to the 0 because it's immediately, right? So it's going to be instantaneously. If you're going to erase all, that was a mistake. I guess I'm not erasing all those little lines, but it immediately means it's going to be at the 0 hour. And this is going to be a b to the third, right? And then we're going to note that this is going to be, so anything to the 0 is going to be equal to 1. So this is actually 800 equals a. And so it's going to be, what we're then going to do is we're going to take these two equations. We're going to put 800 equals a up here. Oh, wait. Actually, we're going to set this up, will be a little bit easier. This is still going to be to a. We're going to put it right here. So it's 800 equals a. This is just the same thing. It's just nicer numbers. And we're basically going to make this a division, right? So this is going to look something like 3 over 8. It's just simplifying this. 300 divided by 800 equals, these cancel, b to the third. So we're going to erase this and put that up there. 3 over 8 equals b to the third. And from there, you can find out that 3/8 to the 1/3, and again, I don't really have a calculator right now, so I'm not going to do that. But 3/8 to the 1/3 is going to be equal to b. And so if you plug that back into your calculator, sorry, or not your calculator, your equation, a of t is going to equal, and a is going to, so a is supposed to be your starting value. You already have your starting value. That's a right there, right? So 800 times, and b is going to be 3/8 to the 1/3. And if you remember from the last video when I explained this, an exponent to an exponent is just multiplying exponents. So if this is all to the t, it's just going to be multiplying. So 1/3 to t, and that's your equation right here. You have that. And then if we want to go even farther and we want to expand the problem, and so we can actually give an example, we're going to find um, the time. So we're gonna say we start at 1 p.m. So we initially start at 1 p.m. And that's just an arbitrary number. It doesn't really matter what time you start at, but just for the sake of this, we're gonna find the clock time. So we're gonna round to the nearest minute. It just makes it easier. When the amount of antibiotic in our bloodstream equals 50 milligrams. So that's what this 50 milligrams equals. And if you notice, it wears. That's when the antibiotic goes away, right? So I mean, I don't know if that really matters, but what we're going to do is we're actually going to take this AFT and we're going to plug 50 in right there. So we're actually going to erase AFT, replace that with 50. Okay? Now, this math isn't all too hard. 50 over 800 is going to simplify to 1 over 16. So we're just going to take this divided by that to basically even it out, or not to even out, to get rid of some of the extraneous factors on each side. So 3/8. Sorry, my handwriting is horrible. 3/8 to the 1/3 t equals 1 over 16. And from there, we are going to have to do some logs, um, which I also went over in the last video, and I'll make sure to link that video. I'll put in the I cards, and then I'll also put it. Yeah, I'll just put it in the I's. So let me rewrite what we just had. And so then we're gonna have to take some natural. Actually, in this one, we'll probably take natural logs. It just makes it a lot easier, I feel. Or we could take logs. It's either way really works. And how this is gonna work is we're gonna take the natural log of this, and then we're gonna take the. I'm just gonna move that over. Wrote that kind of poorly, but we're gonna pretend that that's right there. Take natural log of that. Um, and once you do that, you can actually just get this is equal, and I probably should bring this down. Ln to the 1 over 16 is equal to 1/3 t. You're able to move this over because an exponent inside of a log is equal to it. And it really doesn't matter if it's natural log or log. I just think ln's a little cleaner in this situation because I went over logs last time. I don't want to make it confusing. And I'll go over natural logs in a later video. But once you take an exponent inside of a log can just go to the front of the exponent. So 1/3 t to the ln 3 over 8, right? And then you can just take this and get divided by that. And I'm just going to erase this and rewrite it one last time. Just apologize. It's kind of hard to write on this thing. You turn this entire thing into 3 ln 1 over 16 because you also got to take the 3 out from over there. You have to divide by 1/3, and 1/3, anything divided by 1/3 is basically times 3, so we're going to put it up there. Ln over 3 over 8. That's be equal to t, and that's going to be, if you plug it into your calculator, roughly 8.48, yikes, 48 hours. And so if you started at 1 o'clock, you'll probably be right around 9, or you start at 1 p.m., you'll probably be around 9:29-ish. And if you could say 9:28, 9:30, it really doesn't matter, but it's gonna be around that time. PM, of course. Can't forget so you can't forget PM or AM. And that's gonna be the end of that. That's the problem right there. If you have any trouble, make sure to check out the video. I will be linking it in the eye in the corner. Um, and also rewind the video to get more in depth and go back and try to see where you got lost and follow along. Thank you for watching. See you guys next time.